Now we're going to look at the utility of understanding aromatic, non-aromatic, and anti-aromatic compounds to predict things like reactivity and basicity. So one of the first things we can do is use this concept to predict the basicity of heterocyclic compounds. So for example, here we have pyridine and pyrrole, and we know that in both cases the nitrogen has a lone pair. And in both cases, the lone pair can react with a proton. So if you put either of these in the presence of acid, that lone pair can react and protonate the compound. So this would be the product in each case. So the heterocyclic nitrogen can act as a base. The question is, if you're going to use one of these heterocycles as a base in a reaction, which one is better to use? And we can use our understanding of aromaticity to think about this. What we want to do is analyze this reaction from start to finish, bearing in mind something that is aromatic is the most stable, and then going to anti-aromatic is the least stable. So any process that converts something less stable to something more stable is going to be favored. Any process that does the opposite, converts something more stable into something less stable, isn't going to be favored. So we want to figure out how favored either of these reactions will be. So in the case of the first one, we start with pyridine, which is aromatic. After we do this protonation step, we still have the six-membered ring with 6 pi electrons. It's cyclic, completely conjugated. It's still an aromatic ring. So you're really not gaining anything or losing anything in this process. You're just keeping that aromaticity. If we look at pyrrole, we start with an aromatic ring. But then once we protonate that nitrogen, now we no longer have a conjugated compound. And that's because this nitrogen here is just sp3 hybridized. There's 4 groups around it, the 4 bonds. It does not have any p orbitals. And that positive charge really isn't anything special. It's just a formal charge. So what we have here is a non-aromatic product. In the course of this reaction, we've gone from something aromatic to something non-aromatic. That's not really a favored process. You're going from something more stable to something less stable. So that means the lone pair on pyrrole is much less likely to act as a base. So of the two, pyridine is our stronger base.